Okay, here we have another question from the IB past paper from the MAA SL. That appears to be the question 7 from the May 2023. Now that's a 13-mark question. That's one of those that is sort of would be nice to get as many marks as possible. So I'm going to walk you through the question and check how the marks are getting awarded and what do you have to do in each part. So let's start. The function h is defined by h of x is 2 times x times e to the power of x plus 3 for x belonging to all real numbers. And the following diagram shows part of the graph of h, which has a local minimum at a point A. So here we have a minimum, which means automatically the derivative of x. Actually, it's the derivative of h. So let's backtrack. At A, it has to be equal to 0, right? Because we're talking about stationary point. Stationary point at A. We're going to use this later. To begin with, we need to find the y-intercept, and y-intercept means that it's going to be on the y-axis. Therefore, we have to substitute for x is equal to 0. So the h of 0 would become 2 times 0 times e to the power of 0 plus 3. All of that first part would be equal to 0 because it's multiplied by 0. So the final answer is going to be 0 plus 3, which is equal to 3. So to find the y-intercept, it's going to be the 0, 3. And you will get the 1 mark for showing that you understand that the x-intercept, the y-intercept is going to be for x is equal to 0. So that would be an M1 method mark. And that would be your answer mark here. So this is done. Let's go to the second part, which is all about finding the derivative. So we have that h of x is equal to 2 times x times e to the power of x plus a 3. So the derivative, we have to be careful for the part where we have 2x times by e to the power of x. That means we're going to have to use the product rule for that part. And I remind you the product rule is f times g derivative would become the derivative of f times by g plus f times by g derivative. So let's go and answer that question too. The derivative of h would become the 2x times by e to the power of x plus 3 derivative. That will give you the product rule for the first part. So it's going to become 2 times by x derivative times by e of x plus 2 times by x by the derivative of e to the power of x plus the derivative of 3, which is equal to 0. Let's write it down. The derivative of x is equal to 1, so that's going to give you 2e to the power of x plus the derivative of e to the power of x is e to the power of x, so that's going to stay as 2x e to the power of x. So that was for 2 marks. Again, that question here. So if we assign the marks the evidence of product rule, right, which is here, that would have been a method mark, M1, and the final answer, it's going to be the A1. Now, there's the hence command after that, which means we're going to have to use part B to find the coordinates of point A. So we know that the coordinates of point A is the point for which the derivative is equal to 0, because it's a stationary point. So we're going to have to utilize that. So let's move down here and put the derivative equal to 0. The derivative of x is equal to 0. That means from what we have up here, and let's put it in a box. It's always a good practice to put the final answers in boxes. That means 2e to the power of x plus 2x e to the power of x is equal to 0. Now, whenever you're solving equations, the weirder the equation, the more important is to know that you have to factor and put equal to 0. And what we can factor from here is the 2e to the power of x. And that's going to give us 1 plus x is equal to 0. Now that means that either the 2e to the power of x is equal to 0 or 1 plus x is equal to 0. Now, the thing is, the e to the power of x is never 0. So let's make a little note here about the e to the power of x. The graph of the e to the power of x is like that. So that would never become 0. So this one, not possible, or no solution, which means what we're going to get out of that is that from the second branch that x is equal to -1. And that's a solution that is accepted. Which, if I look up on the graph, it kind of consistent with the location for that. That happens for -1. So in order to find both coordinates, because I've been asked to find the coordinates, I'm going to have to calculate the y coordinate of A, right? Which is going to be the f of -1. So let's just write it down here. So point A is going to become the n minus 1 f of -1, with the f of -1 to be equal to 2 times by -1 times by e to the -1 plus a 3. That's going to give me -2, and e to the -1 becomes 1 over e plus a 3. Therefore, final answer is going to be that A will have coordinates -1, comma, -2 over e plus 3, and then put that in a box, and we're good. Now we have 5 marks for that. So let's see how this is going to be assigned. M1 would be for having the derivative equal to 0, and then having some sort of correct working or an attempt to solve it, like this stage where we did the product, that would be an A1. And then, of course, the final answer that x is equal to -1 is going to be another A1. And the difference between putting it into brackets and no brackets is the ones in brackets, they can also be assumed. So if you ended up with x is equal to -1, you will get both marks, both the one in brackets and the one without the brackets. So there's 3 marks up to this point. The 4th mark would come by substituting the f of -1, and that's going to be another method mark. And then the final answer will get a mark as well for the corresponding value of y. And these are the 5 marks. Moving on, we already have the first derivative, and we can see it up here. And we've been asked to calculate the second derivative, so we're going to move on with that. So the second derivative of h, which is the derivative of h, that's going to become the 2x e to the power of x plus, that's not the correct one. Let's pick up the correct derivative, which is the one here, right? That was the answer. So we want to find the derivative of 2e to the power of x plus 2x e to the power of x derivative. That will give us, again, an opportunity to do another product rule. So for the first part, we don't have a product rule, which is just a coefficient in e to the power of x. So that will remain as 2 times e to the power of x, because the e to the power of x derivative is equal to e to the power of x. And then we need the product rule for the second part, which is going to become 2 times the derivative of x, which is 1 times e to the power of x, plus 2x times the derivative of e to the power of x, which is e to the power of x. And if we see what we actually have here, we're going to have 2e to the power of x plus another 2e to the power of x. That would give us a 4e to the power of x plus 2x times by e to the power of x. The thing is, if you see what we have, it's a show question, right? Show that. So that means that we have to put it in that format because it doesn't match exactly. If we see what happens in the question, show that it says that we have to factor the e to the power of x. So let's just do that. E to the power of x, that's going to give us 4 plus 2x, or otherwise 2x plus 4 times by e to the power of x, and then QED, because we have shown what needs to be shown. Now that was for 2 marks, and for 1 mark essentially would be the use of product rule, and at the same time the fact that this has been correct. This is the answer given, AG, so you don't get a mark for that, and that corresponds to the 2 marks that we see up here. Moving to the final part, it has to do with concavity. Find the values of x for which the function concave up. Now, the concavity part, concave up, it's associated with the fact that the second derivative of x is bigger than 0. So we're going to have to try to find out for what part the second derivative, which we found just above, concaves up. Now we have the second derivative of x is bigger than 0. That means the e to the power of x times by 2x plus 4 is bigger than 0. But what we do know, and we discussed it earlier, the e to the power of x is always positive. Because remember that the graph goes like that, so it's all about the x-axis, which means what I have here, it's going to be positive, with this one being positive only if the second part is also positive. So we want that to be positive. So 2x plus 4 to be bigger than 0. Take away 4 from both sides. That would leave you with 2x bigger than negative 4. And then divide by 2. X bigger than negative 2, which is going to give you the final answer. Now, that was for 2 marks, which is quite reasonable. So the first one would be the condition to know that concave up means that the second derivative is bigger than 0, and then A1 for the answer, and that's going to be the end of that question. Really good question. You should perhaps to review it or even stop and try